All right, here we have a 0.25 kilogram pool ball moving at 5 meters per second easterly towards a second identical pool ball, which is at rest. After the collision, the first ball slows down from 5 to 1 meter per second. What's the final velocity of the second ball? So the whole idea of collisions and explosions is that your total momentum before has to be equivalent to your total momentum after. You look at all the objects, all the masses involved. So it's a sum. We add up all the momentums before, and whatever that is, it has to equal all the momentums after. That little symbol I use, sigma, is a Greek letter for sum, just easier than writing the word sum of. Now remember, momentum is a vector, so we've got to watch the directions. Got to be careful with that. So let's set up the before situation with a picture. Before, we have one pool ball in motion, and it weighs 0.25 kilograms. Its mass is 0.25 kilograms, and its initial velocity is towards the east, and that is 5.0 meters per second. Let's call that V1 initial. Now the second pool ball is not moving, it is stationary, so it's sitting here at rest. An identical pool ball, it's 0.25 kilograms as well, and its initial velocity, V2 initial, is 0. So that's our before situation. Now let's look at our after situation. After they collide, the first pool ball then slows down as a result of the collision. So imagine it's over here now. And it slows down to only 1 meter per second. So I'm going to call that V1 prime for a final velocity. And that's 0.25 kilograms. The mass hasn't changed. We're trying to figure out how fast V2 is going. So we want the final velocity, which is unknown. I'll go like this, a little question mark, but it's after, V final prime. What is that value? It's still 0.25 kilograms. So when we set up our equation, our total momentum before really is only the one object. In order to have momentum, you need mass and velocity. So my total momentum before consists only of object 1. So P1 initial is my total momentum before, and that has to equal, well, I've got actually two objects moving after. That has to equal P1 final, little prime there, plus, and now we've got a new momentum, P2 prime. And all we got to do is put in our formulas, make sure our units are okay. Well, we've got kilograms and meters per second and everywhere, so we should be good to go. So P1 initial, let's put in our values. Mass times velocity, 0.25 kilograms times V1 initial, which is 5 to the right, so we're going to say that to the right is positive, equals P1 final, which they told us was 1 meter per second. So still the same ball, 0.25 kilograms times 1 meter per second. It's still to the right, so it's still positive. Plus, and then the other ball, same mass, 0.25 kilograms. And we're looking for V final prime. Now, you can sort this out and do the algebra, but one thing I noticed right away is that you've got a 0.25 kilograms in every single term. And if all these masses are identical, we can actually cancel them off. So really my equation is 5 equals 1 plus V final prime, which is quite simple to solve. And you end up getting your V final prime to be equal to 4 meters per second. And we get a positive answer, which we've decided was east. The sign will come out when you do momentum.